Hey, it's Wayne/Roby. I'm out here in the shop and I wanted to share a little piece of software I've written with you that if you build precision navigation robots, in particular auto mower robots, then I think that this software may be of interest to you. You can go to the website precisionmule.com. And I want to note I use Chrome and I haven't tested the website on anything other than Chrome. So this is all open source. If you find any bugs or whatever, feel free to hit up a pull request and I'll be happy to support whatever browser you'd like. But precisionmule.com is an application that builds missions for. I use it for my auto mowers. So if you're in the Ardupilot world, you know that Mission Planner is the standard software for configuring robots, calibrating compasses, um, building missions. But there is a kind of mission building that I like to do for my mowers that you can't easily accomplish in Mission Planner. And so I wrote this website to basically do what I need out of an autonomous mower. So let's jump right in. You'll notice that it's really just a big Google Maps interface with a few buttons and a text field over on the right side. So I have zoomed in on my house where I do a good bit of mowing. And let's go ahead and I want to draw an area over here in the side yard that I would like the mower to mow. So I'm going to just click and draw a polygon. Let's say it looks something like that. And then I've got a little area that I have to cut around in there. Okay. So now that the polygon's drawn, I need to know what distance between the passes that I want the robot to go. So whenever it goes up and down, how far do you want to center the lines? So for the robot that we're dealing with today, we need half a meter, so that's 50 centimeters between the lines. So let me just go ahead and click Build Mission. And you'll see that there are a lot of mission points inside of this polygon. If we zoom on in, you'll see that the distance between each of these lines is actually 50 centimeters. And what the application does is it takes the path that we defined initially, and when you click Build Mission, it actually uses the first point that you entered as the starting point and the second point as the guide point. So the heading between the first and the second point is actually going to be the heading for all of the lines. And it builds a mission inside of the polygon that you define. And so what we would do is we would go over here and click Download Waypoint File. And Google Chrome gives us a little warning there saying it's not used to waypoint files. We can go over to Mission Planner. And now we can go to Load Waypoint File. Open. And just like that, you have, a 106 point file for that your robot can use to chart its path to mow the grass.
Okay, so imagine that you built that original mission with the original polygon we built. And remember that down here at the bottom, this was the first coordinate we drew. Up here at the top right, that's the second. And so the angle between those two, or the heading between those 2 points, is the heading of all of the lines. But imagine if you said, the heading here is something a little shy of due north. Maybe that's 356 instead of 0. And I want to pull it over to be straight up and down, so north and south. And so that's about right. So all you'd have to do is drag the coordinate over and then click Build Mission And now notice that the lines, if I zoom in, it might be more clear. They're basically north and south. So imagine that you built this mission, and you said, I really want to be a little bigger than this. This was a starting point, but I've looked around. I see a few more areas that the mower can mow. The thing to do there would probably be to click Save Polygon, and go ahead and that saves the polygon you've drawn into your browser. Go ahead and click Clear Map. Load the polygon back up by clicking Load Save Polygon. And now let's make some adjustments. Let's say that we wanted to go ahead and mow up. There's a tree right there. Let's do this. Let's mow up through there. Then take that and then pull that down. Like that. Get around that tree. And then go right in here. And then go up through here. And then up. No, maybe to about right there. And then get down. Try to skirt around that tree a little bit. And suppose that we could do something like that. Yeah. We're just trying to cover the backyard. And of course, you'll have to eventually get out there with the robot and see how close Google Maps is maps up to reality. Go ahead and do something like that and click Build. And notice that we have a mission that's covering the area. Now, the algorithm it's still a work in progress, and really it's just going. It starts off and makes a line between the first 2 points you draw, and then it looks to either side, and the side that has the most area, it says, I'm just going to go that direction. Okay, so we've built our new mission, and notice that we still have the width of the path at half a meter, 50 centimeters. Suppose that we've got a bigger deck. We can push that up to 1 meter, something like that. Just click Build Mission. You'll notice that the waypoints are a good bit, well, they're twice as far apart now. Now, I have a little bit of a bug in the algorithm, such that it always ends the line between the first point, the guideline, at the guideline, so it doesn't actually push to the end. So if you want to overcome that, you're going to want to just pull the guideline, pull it up to the end, like that. Yeah, and now click Build Mission. There we go. Now, so just to kind of reinforce what's happening here, this has built a mission of Ardupilot waypoints in the mission waypoint file format. So we can go ahead and download the waypoint file, make sure I know which one this is. That's mission 1. And then jump over to Mission Planner and load the waypoint file. Just like that, we've got waypoints. One last thing I'd point out is, so I added this Save Polygon feature, and that is, a lot of times I'll end up spending a lot of time getting the outer perimeter just right. I just want it to miss a rose bush, or I want it to just go around this tree, this kind of thing. And it may be hard to, a good bit of work to recreate the polygon. So what I did was, both you can click Save Polygon, and that'll just save it into the browser, but that's kind of, you can only save one instance, right? The next time you click Save Polygon, it's going to overwrite. All right, so then that's, now that the browser has this shape saved. But if you click Download Polygon File, that actually that downloads a polygon.json file, which is just a JSON file of latitude, longitude coordinate pairs. And what we can do is, you can actually import that file back into the application, and you'll get back the polygon that you define. So it's just a way of saving your work and not having to hopefully keep you from having to lose anything you've worked on. But I think that's it for now. This app it's definitely a work in progress. I don't think I mentioned it, but the backend is actually a little Java application. It's a servlet with some Java code that does the path building, and all of this is open source. So definitely contribute if you like, or point out any features you'd like to see, as long as they're not browser support bugs. I'll have to get someone else to do that. I just can't stomach it. But hey, thanks for watching, and look forward to seeing you again soon.